Good afternoon and good morning, good evening, wherever you are. My name is Onno Roel. I'm the General Manager of the Aga Khan Agency for Habitat, and I'm really happy to welcome you to this webinar on green construction and green architecture. At the Aga Khan Agency for Habitat, we're very happy and proud about our partnership with the Institute for the Study of Muslim Civilisations at AKU. We did a first webinar just before the new year, and we're very happy to build on that and even build further with future webinars. Today, our conversation is a build out of last time when we talked about AKAH's work on climate change adaptation. Why is it a build out? Because climate change is increasingly at the center stage of the AKDN's work, under the guidance of His Highness and the driving leadership of Prince Rahim, who is chairing a new committee called the AKDN Environment and Climate Change Committee. In this context, he has asked us to measure our greenhouse gas emissions across the network, and he set the goal that the network should become a net zero carbon network as soon as that is feasible. And in looking at what it would take to achieve this goal, which by the way is certainly feasible, we realized that a big part of our emissions came from construction and the operation of buildings. And since many of you who know the AKDN know that the AKDN is a network that does a lot of construction and operates many buildings and facilities, we realized we needed to work on this. It very nicely brings together the historical work of the network for architecture as one of the innovators for architecture, particularly Islamic architecture. And therefore, we're really excited about today's panel. We'll start off with Dr. Risto Dikanski, who is the green construction expert at the Aga Khan Agency for Habitat head office. He will set the stage by explaining the importance of green construction, what it entails, and how to go about it. So without further ado, I have a few housekeeping announcements. First of all, this webinar is being recorded and will be shared on AKU and AKDN YouTube channels. It also means that you should realize that if you speak during the webinar, you are being recorded. Secondly, at the end, we'll have a question and answer session. Feel free to type your questions anytime. We will only get to them at the end, but that will allow us to have a lively discussion. If you want to actually put your hand up and speak and ask your question, that is also possible, but we've learned from experience that the chat window is a very useful feature and that people like using it, so feel free to do that. And then once again, I want to thank AKU's Institute for the Study of Muslim Civilisations, as well as the Aga Khan Trust for Culture's education program, who we are working with in this series of webinars. So with that, Risto, over to you.
Perfect. Thank you very much, Onno. Welcome, everyone. Could I just double check that my screen is visible? Onno, could you confirm?
I can see it.
You can see it. Perfect. Okay. So welcome, everyone. My name is Risto Dikanski, and I'm happy to be here today with you and talk to you about the Aga Khan Agency for Habitat and our green construction and green building program as an important part of the agencies and the wider AKDN's efforts for decarbonization on our way to reaching net zero. So to set the scene, I want to highlight the importance of buildings in global greenhouse gas emissions. So buildings are responsible for about 39% of all of the carbon emissions going into the atmosphere. So about 11% of this comes from construction. So this is the embodied carbon in the construction materials, and the rest is through operation of facilities. So this only highlights that it is quite rightly that the buildings are a key focus of global decarbonization efforts, and so are they also for AKDN. Going a little bit further into new construction, you can see that globally, about half of the buildings that we're going to have by 2060 have not been built yet. So this is equivalent to a whole New York City built again every month for the next 40 years. That firstly shows a challenge of a whole lot of new emissions we can expect to come in through construction and operation, but also it is an opportunity to build a green New York City every month. And when we look at the data a little bit further, you can see that this is particularly big. This opportunity is particularly big across Africa and Asia. So whilst in Europe and North America, most of the buildings that we'll have by 2060 have already been built, and there the biggest challenge will be about greening our existing building stock. Across Africa and Asia, there will be a huge boom of construction over the next several decades. And this is also where AKDN is very active. So we have a big opportunity to make these buildings green and to embed green performance and principles there from the outset. So new construction provides a great opportunity for climate action, especially across AKDN geographies. And to achieve this, green design is key. We can retrofit green performance, and this is possible. However, when we do this from the outset of the building design, planning, and construction, it is more powerful. We achieve better green performance, and we do this a lot more economically. So we achieve more with less. So how does AKDN approach this? Last year, AKDN introduced a set of green building guidelines covering all our new construction projects and all existing buildings. So these guidelines are applied across all new projects. They cover a set of themes, which are materials, greenhouse gas emissions, energy use, water use, and importantly, adaptation. Across our built environment work, we are ensuring that climate change mitigation and adaptation go hand in hand. So not only are our buildings green in the sense that they emit less and contribute less towards global climate change, but also we are striving to make them resilient and adaptable to the challenges that climate change is bringing, and they provide comfortable environment even in the new climate. The green guidelines take a life cycle approach, so they address all life cycle stages of a building, starting from planning, deciding that we want a new building, through to design, construction, all the way through operation and maintenance, and through to the end of life and decommissioning. Today, we will focus on new construction. So the overall philosophy for new construction may be counterintuitively, when we're building, the greenest way to build is not to build. So this certainly doesn't mean do nothing. Build nothing is all about going back to the principles of our objectives. What are we trying to achieve through construction? Is it providing affordable healthcare to communities? Is it providing widespread education or safe habitat that enables communities to thrive? Whatever our objective is, we are now a standard as part of the feasibility discussions of a project, going back to the original root objective of what we're trying to achieve and seeing, can we achieve this without building? Can we use what we already have, repurpose an existing facility and refurbish it? So that we can achieve our buildings in a green, our objectives in a greener way? Can we leverage the use of technology to achieve our objectives? All of these are not only powerful carbon reduction and green approaches, but also very much cost effective. So they directly relate to large cost savings. So they're very interesting, and we are starting to consider them seriously across all our new projects. And the next step is building less. Can we utilize our space more efficiently so that we can meet our objectives through building less? Can we expand what we already have? And so on. And then finally, when we've decided that we do need a new building, which is often the case, we focus on building clever, using greener materials, using greener techniques, so that our buildings our buildings use less resources and are comfortable and safe in a more efficient way. So taking this on building clever, we'll start with what our buildings are made of, so materials. And this picture is one of our projects in northern Pakistan, and this is relatively representative of a large part of construction in the region, and it is with reinforced concrete. So a lot of our construction currently is still with reinforced concrete or with steel structures, and considering the large volume of construction that we're expecting in our geographies, this is concrete is likely to play an important part of this journey. We are happy to see that we are already having low carbon alternatives to traditional concrete penetrate the market across, for example, East Africa, across Pakistan and India. And we're seeing some solutions offering up to 30% less CO2 for concrete than compared to concrete using ordinary Portland cement. Whether this is through cement replacement or through other adjustments of the formula of cement. So this is really important, and we're already exploring how to use this on our projects. But even taking a step further, we're looking at completely different materials to substitute concrete with more and more. And what's exciting about this is we are looking at traditional materials, but we're giving them a more modern application. So what you're seeing here is some pictures that I've borrowed from the Oroville Earth Institute on compressed earth and using compressed earth as a construction material. We are currently leading together with Oroville Earth Institute, a training program for our teams in Syria, enabling people to not only design, but also design and build, but also manufacture these products. This is a really interesting product because it is more climate friendly, it is very low carbon, it is locally available, it is affordable, and also it gives rise to economic activity locally. So it helps people improve their lives, not only through building robust and resilient buildings, but also through economic activity. I'm just going to show you a couple of these examples. The next one is sustainable timber. We are more and more looking for opportunities to use sustainable timber in our construction. Of course, timber has been used in construction for thousands of years. We are looking to revive this in a very importantly, I repeat, in a sustainable way. So we are looking to introduce safeguards to make sure that the timber is sourced sustainably and it doesn't contribute to decarbonization. And this is actually a very powerful, to deforestation. And this is actually a very powerful way for reducing carbon in buildings. And even buildings can become a sink for carbon, and they can be net zero or even carbon negative in some cases. So we're working with our partners from the Climate Smart Forest Economy program to explore how we can use this material and how we can prepare the market in some of our geographies to be able to do this more at scale. And we're starting with solid timber, but we are hoping that will help the market evolve to start using engineered timber products like glulam or even cross-laminated timber. So these are a couple of examples around greener materials. Let's move to energy use. When we talk about energy use in buildings, particularly for new construction, there are two aspects that we consider as part of our green building guidelines. One is reducing the energy demand through passive design measures and through using efficient design. So this can include the use of insulation to retain the heat within the building where we want to reduce losses. Orientation is a very powerful powerful consideration, where we can orientate the building towards the sun in cold geography so that we can maximize solar gains, or away from the sun in warm geographies so we can minimize this. Also the size and the location of windows, as well as efficiency, the use of shading, all of these are really powerful way to reduce the energy demand of all our buildings. Some of them we can also use as retrofit. For example, insulation, efficient equipment, we can use as a retrofit. It is more costly to do that stage, but still important solutions. However, something like the size of windows, orientation, this is really important considerations early on in the design. The second consideration around energy is about the source of energy. Where does the energy come from? We have reduced the energy as much as we can, and now we need to source the remaining. And the reality is, at the moment, a lot of our facilities, at least partially, rely on generators burning fossil fuels. This is partly because of considerations with grid reliability. For example, many of the rural locations we work in don't even have access to the grid, so they have to rely on solutions like this. Those who do, those locations which do have access, the reliability of the grid is low in many cases. So at least partially, there's a reliance on generators. In AKAH, we have already started our journey on phasing out generators. We are starting to introduce on-site renewables, as well as exploring off-site renewables, and starting to create a plan for phasing out all of our generators over the next few years. We are exploring the use of sustainable biomass for heating of water and spaces, as well as various heat recovery options, including heat pumps. All of these are part of our AKAH level decarbonization efforts. So how do we measure all this? AKDN has started using the EDGE green building framework. EDGE was developed by the IFC, the International Finance Corporation, as part of the World Bank Group. And it is similar to other green building frameworks like LEED in North America, or BREEAM in the UK, and so on. But it is different in terms of the fact that it is specifically tailored for developing economies. So it targets Africa, Asia, and South America. As such, it is more applicable. It is very applicable. It is simplified, and we're finding it is quite useful as a design support tool. AKDN has utilized this and introduced a minimum green standard for all new construction. So this includes 40% reduction of operational energy compared to a local baseline, as well as 20% reduction of water use and 20% less embodied energy in the materials. So this is the minimum standard for all AKDN construction, but some of the bigger and more substantial projects will have even stricter standards to ensure that buildings truly support AKDN in our journey to decarbonization and reaching net zero. So I just want to close by reiterating a couple of points. Buildings are an important emitter. They emit almost 40% of global GHG emissions, and they rightly are a focus of a lot of global efforts on decarbonization. Construction specifically offers a great opportunity for climate action, especially in Asia and Africa, where AKDN is very active. And to leverage this in an economical and effective way, green design is key. We need to get in early and start incorporating green considerations from the very start of our planning and design for the new built environment. Thank you very much. Back to you, Arno.
Thank you so much, Risto. Thanks. That was a great way to set the stage and give a lot of information to the participants. There will be a question and answer session at the end, but I know that some of you have already shared your questions on the chat window. These are being tabulated, and we'll get to them at the end. It's now my real pleasure to introduce Sana Darani, who manages community programs designed for housing, sanitation, and institutional building, as well as the greenhouse gas emissions management program for AKAH in India. For me, she's the climate change focal point in AKAH India. The rest I frankly don't care about. She has been a great resource for the training of various AKAH agencies on greenhouse gas measurements, working closely with Risto and the team. She's an architect by education with a master's in environmental architecture and an accredited professional with the India Green Building Council. And she will share with us what Risto's framework means for the programs in India, some concrete examples. Sana, over to you.
Thank you, Ono, for the lovely introduction. So welcome, everybody. Good afternoon and good evening to everybody who's joined in. Just confirming my screen's visible?
Absolutely.
Okay, perfect. So today we're going to go from the global vision to the local action, particularly the green building movement in India and what we've been doing in the Agency for Habitat in India. So how is India gearing up to go green, and how we're going from designing green to building green, some of the initiatives in green construction, and then finally understanding what's green retrofitting and how we're doing it in some of our projects. So before we start, just taking you all through some of the key statistics. As we started off the green building movement in the year 2001, and now we have over 7 billion square feet of registered green building footprint in India. We also have a mandatory code for all the commercial buildings and a voluntary code which is specific to energy conservation. But we also have a huge gap in housing, over 60 million houses to be built in urban and rural areas. And this is going to contribute to a lot of emissions. And as such, India is already one of the 4th largest contributors. Although the per capita, that means per person, the kind of emissions that we do in India is lower, but considering the kind of population that we have within the country, we do contribute to the global emissions quite significantly. So let's move on and see how we're designing green to be able to build green. So everything starts with a vision, especially when it's architecture, and people are the focus for whom we design buildings. So we've used this concept of bioclimatic housing, which I'd like to just explain very quickly. It defines the relationship between how you design with keeping the climate, as architecture is a response to climate as well as culture. So bioclimatic housing looks at the preferences, the lifestyle, the user's comfort, and the climate in context, and then designs the building form and fabric to be able to give a comfortable building. So using this design principle, we've done a number of over 150 rural houses which have natural ventilation, daylighting, and significantly reduce the heat transfer. So basically in green design, you make sure that you use the 3 important elements of nature, the sun, wind, and light, as Zed Brown has indicated in his architectural design principles. So we look at how the kind of the heat of the sun kind of interacts with the building, which is the area that is exposed significantly, such that you treat that rather than treating the entire building. And then you also look at the kind of movement of the sun annually over the building, such that you can design simply a simple element like a sunshade, allowing the winter sun to come in, so that you can have a passive heating that you do not need to spend on heating when it's cold. And the sunshade during summer kind of blocks the sun and avoids overheating the building. So these are the some passive design principles, as we call them in architecture, that basically we do not spend energy, but we still ensure that the building uses less energy during its operational phase, like when people are occupying it during whatever the life of the building is. Coming to how you allow the wind to come in by orienting, especially when it's a low-rise building, more than the sun, it's the wind that you want to take in. If it's a warm and humid kind of a weather where you can naturally ventilate the house by providing the required number of openings, as well as the size of the openings, as well as the location, such that you can build like a draft of air, cool air coming in, and landscape your front yard. So these are small little things in design that can ensure that your building is using less energy, but providing the required comfort to the occupants. And openings play an important role in getting the daylight, so that during the day you really don't need electricity. And now that we're spending so much of time at home, we realize the importance of having a well lit home, where it's so comfortable to sit, work, study in the daylight. So these are some pictures which of one of our projects, rural housing. This project is of a group housing where the whole master planning is done to ensure that you're taking in the advantage of the prevailing wind direction and the daylight and the cross ventilation. So ensuring that you design your units in a way that is when you do a multi-story building, it generally tends to get difficult to ensure daylight and ventilation to each. But that is critical, because the more effort you give in the design stage, the better the building is for the users, the more comfortable and the more efficient, resource efficient in the long run. So moving on to some of the initiatives during construction, and important things taken care of is using local material, so that you don't export from long distances. And again, if you can salvage during a reconstruction project and reuse some of that debris for filling up, that's one way you can reduce the use of new or virgin materials. Using fly ash and autoclaved aerated concrete blocks, which are generally known as AAC, that's something that will reduce the weight of the building. So the leaner the building, the lighter the building, basically you will spend less steel and concrete for the structure of the building, and that's where you will save even on the cost as well as on the embodied energy. And using high reflective wall paints and roof paints to again ensure that your building doesn't take the heat, because I'm talking about India, where majority regions require passive cooling. So that's where you design the skin or the fabric of the building in a way that you end up using less energy during the life cycle of the building. Coming to water, yes, rainwater harvesting and recycling wastewater on site are two important, I would say, features that are easy to incorporate at the design stage, especially if you do have a landscape area where you can, for example, in this, we've used a zero energy plant-based filtration system that gives you, over 68,000 liters of treated water. And, that's where in areas where you have an issue for water security, going green during construction by taking care of the wastewater that will get generated, you can ensure water security in the long run. We've already looked at how net grid rooftop solar systems can be integrated, and this is one of the design projects where we've ensured that it kind of is not an add-on, but it is along with the design of the building, that we can have the solar panels on the roof and have a cool roof and a cool wall or a high reflective kind of a envelope that will ensure that the building doesn't get heated, so that you don't have to spend too much on cooling it. And again, you have your rooftop solar that will ensure you are exporting to the grid and while you are using the energy from the grid. And yes, we have an emission management program since 2017, where we are looking at what kind of emissions take place due to the construction, and we try and reduce it, especially in all our community programs, by using local labor and material. Moving on to green retrofitting. I'm not sure how many of us have really heard this term. It's relatively new, but I'm sure that in many different contexts, we've come across it in one way or the other. So it basically means you have a good set of existing buildings that have a potential to go green, that have a potential to get more resource efficient. That means you can use less material, less water, and less energy even after the building gets constructed. So when you're doing repairs, you can use green certified, and that's some of the projects that we've explored using low volatile organic compound paints and waterproofing materials that are again certified green and give long life to the building, such that when you elongate the life of the building, you're reducing the need to reconstruct in the near future. Then we have, this is one of the cool roof applications we've done on our project. The second is solid waste management. I think this is more of an urban, peri-urban issue, but slowly we are finding the landfills are getting bigger and bigger. So having a decentralized waste segregation and composting the waste by, this is an example of a zero energy tumbler system where you can create the manure, your compost, and use it in the landscape right on site. So this, as we know, more than 60% of our waste is biodegradable, and it can be easily managed at site. Coming to rainwater harvesting, so that's not just a way to ensure water security, but also a flood mitigation in cities like Mumbai, which have always seen these flash floods. So when you have a lot of rain and you have a harvesting system, that also ensures that you reduce the flow, the runoff basically on the streets, or the drainage system, which is already overloaded. So this is something that complements to water security as well as a mitigation to floods. Using aerators are very simple, that you can fix them even in existing, and this is what we've been doing through our programs by creating awareness amongst the community that by simply having these fixtures, you can considerably reduce the water flow, especially in areas that are water stressed during certain months of the year, like summer. And with energy, again, installing a rooftop system is still easier in an existing building if the structure permits. And we've had many such examples of individual houses and now community housing coming to us for understanding how technically feasible it is going to be to install solar rooftops, such that they can bring down the energy of their common areas in the building, and promoting the use of more energy efficient lighting and rated equipment. So this is greening existing buildings, but there's one more important, or I'll say an interesting way to do green retrofitting is avoid building. And that does not mean, like this slide is, have nothing, but it means that you refurbish an existing building for a new use. It's also known as adaptive reuse, where you take an existing building, and I'll give you an example. We had an office space, and we decided, instead of, if the building still has a life, why don't we do a spatial planning such that we can reuse it as a training center instead of reconstructing it. And we've included all these design features into it. This is how it looked before construction, and certainly it's like a 40-year-old building which we had to redesign. So looking at flexible spaces which are multi-purpose, open grid kind of ceiling, that is when you don't use false ceiling. That saves a considerable amount of cost as well as embodied energy, because you can really have a nice neat grid for your conduits, for your electrical fixtures, which if designed well, you don't really need to hide them out. And this is finally how it looks when we say avoid building. So we've retained the building, but we've ensured that it fulfills the need that we have. So that's it. Over to you, Ono. Thank you.
Thank you, Sana. Thank you for bringing that to life. And I especially liked showing how you can repurpose a building and build something useful, and that way retain something, some value, and use much less of the resources. Thank you very much. It's now my real pleasure to introduce Saif Ul Haque, who is the principal of the Dhaka-based architectural practice, Saif Ul Haque Sthapati. I guess he's the boss there. He's involved in the practice, research, and education of architecture. He's received many awards at home and abroad, and for us, particularly relevant, and for many in the audience, that he is one of the winners of the Aga Khan Award for Architecture in the 2019 cycle for the Arcadia Education Project. We're very happy to have Saif, and he will speak to what he learned from that particular project, the project for which he famously won the Aga Khan Award for Architecture. Saif Saab, over to you.
Hi, can you hear me now? I mean,
we hear you and we see your slides. Yes, yes.
Great, great. Thanks, Ono, and thanks, Tushna, for uploading the slides. It seems that we are much ahead from those days of slide projectors, but even digital connections at times doesn't work. But I'm very happy to join this webinar on green construction and green architecture. It's kind of a very timely thing, because I think in few hours' time we have a new president in the United States of America, and hopefully United States of America will be back in the climate change agreement, the Paris Agreement, which has been very much kind of a worrying thing for everyone. So my presentation is basically on this project that we did. I mean, the project started almost 10 years back when I had the first opportunity of going and seeing the site and meeting the client. And so my slides are arranged in a sequence from the very first experience of the site, and then gradually following on the design. So let me introduce my client, because in any architecture project, any design project, I mean, there are many actors, and one of the main actor, the important actor, is the client. So here is Razia Alam. She is a retired school teacher. She was teaching in the UK, and then after retirement, she decided to come back to her home country, Bangladesh, and do some social welfare work. And she started a small school for preschool children, and alongside the school, she had a small nursery, and she has interest in plants, flowering plants, fruit plants. And she was operating that school in a rented premise, but she had to leave that place as that lease was expiring and the landlord didn't want to extend it. So she decided to buy a piece of land, and the land that she could afford was next to a river. So in the next slide, you can see this was in September 2011 when I first went to see the place. And when I went there, it was post-monsoon, but even in the site, I saw there was water, and then so this is what she showed me, that this is where she wanted to build a school, and then she was not exactly in much of a rush because she needed to mobilize her funds and everything. So she wanted me to think about it, that what I could do. In the next few years, I kind of observed the place, and you can see in the next slides that this is how it appeared in different periods of the year. In dry condition, it was land, and during the rainy season, the monsoon, it was underwater. So initially I thought that what can be done over here? The conventional practice is to sort of fill up, raise a mound and construct. But here we had a particular landscape situation, a geographical condition which we call floodplains. And Bangladesh, in the next slide, I will show you the floodplain map of Bangladesh. So this is the monsoon condition. So it's all underwater. Next slide. So this is how Bangladesh topography is like. The gray areas are the floodplains, which means that every monsoon, these places are underwater, or they're sort of flooded in different degrees. And how can one build in this kind of condition? So what has been happening lately with the use of technology, people have been filling up this kind of landscape conditions with sand and making it a level condition, which was kind of an environmental problem. I mean, these were very precious ecologically, but somehow wholesale filling up was altering that characteristic. Next slide. So this is how technology was helping to fill up this valuable wetland condition. And we needed to sort of devise ways how to inhabit this particular floodplain condition. And for this particular school, what could be an appropriate solution? Next one. So once we fill up, it kind of transforms into this kind of a dense urban condition because land is quite scarce, and we are yet to sort of devise ways of creating a condition of living where we have the water and where we have the land, and we also have the buildings or the infrastructure. So we follow this kind of a technique to cover. So to me, the option was what to do. So I initially thought of the traditional option of filling up and making the school building over there, but I was not exactly sure because one was that the site was too narrow. If I was filling it up, I required a lot of retaining system of keeping that piece of land raised above the flood levels. The other option was to build it on stilts. When the water comes, the building could be free of the flood if it was high enough from the flood level. And the third option was to try out something new, an amphibious structure. So when I shared these options with my client, she was very enthusiastic about the amphibious option. But I have to tell you that this was a kind of an untried thing over here. We do have floating structures. We have a lot of boats and other river crafts and all these things. We have pontoons, we have rafts, but somehow an amphibious structure for inhabitation was not much of an use in Bangladesh. Next. So initially the conceptualization was trying to sort of mediate between a very sophisticated technological solution and a kind of a crafted traditional solution. So we tried to develop a design where we could use the idea of a raft with a pavilion, a lightweight pavilion that will sort of float when the water is here and rest on the ground when the water is not there, and using very lightweight material. And we thought the most lightweight material that we could use was bamboo, which was very easily available in the site and the surroundings. Next, please. So we presented an idea. This was the visualization that we presented to the client of the school, and she wanted to have the entire school built at one go. She had a very modest requirement, 3 classrooms, 1 office, and the other support thing. So we offered her this vision that you could have a place where it will be on ground during the dry condition, and the water comes, it floats. Next, please. And this is the plan that we worked out. The site was a rectangular site. An obvious solution was a rectangular structure. But what we did, we made each of these classrooms and other functions as separate modules in order to sort of make it more flexible operation for the water condition, instead of having a long fixed structure. We had separate modules which were connected to each other, and there were some guideposts that will sort of help it to float and then settle again on ground. And we needed to create a level condition so that when they're resting on ground, they're on a flat ground. Next. And this was the assembly diagram of the modules, and from the substructure to the superstructure, each of the components were sort of made off-site or close to the site, and then they were assembled in the site. And we used for the substructure, after making the ground level, we used some used car tires so that the structure could rest softly on the ground. And then we use what we call upcycle steel drums, the drums which were used earlier for any other purpose, and then we used it for the raft, the floating purpose, then within a bamboo frame, and then we had bamboo posts, bamboo floor, bamboo roof. So everything was bamboo. So this is one of the modules how we were going to assemble it. Next. And then the construction began. The construction began in the date, 2015. It was December 2014, I'm sorry, 14. And it continued throughout 2015. And the construction was carried out even during the monsoon of 2015. So we had to rush with the substructure work before the monsoon came. And so the work continued during the monsoon. Next, please. And then the water receded, again it became dry, so we continued with the work. Next. And this is how we recorded the flooding of the year 2016, that how the water gradually came to the site and then it was totally submerged, but the school kept on floating. Next. And this is the two situations. The dry condition, when the river is receded, it is in the channel, and then in the monsoon, it is all flooded. Next. And in 2019, this is how the school looked when it was nominated for the award, and it made it to the shortlist. And so this is the spring 2019. The school was in this condition as photographed by the award team. And the same, next, yes, next one. And the same year in the monsoon, the school appeared to be like this. Next. and the same year an aerial photograph. So it, as mentioned before, it was something that we were trying out kind of for the first time. It was an experimental project, and we didn't sort of visualize a lot of issues that would happen in a dynamic condition like this. And we had to also carry out some repair and renovations as the years went by. But sadly, last year we encountered a very serious flood, and it was during this COVID pandemic period. So we were not being able to carry out much maintenance in 2020. So this year, the dry season is here, and somehow we have to sort of make some more repairs and make it sort of back in its original state. And we also plan to make it a bit more robust while we do it. So in this, the lessons that we had learned from that, that is one thing that is sort of particular for this kind of condition. But how do we take it to other situations? How do we kind of upscale it? How do we make our building construction more green? So in another project of ours, which is ongoing and which you'll see in the next slide, and this is in an urban context where we're putting up a multi-storied apartment building, a multifamily unit. So here we are trying to incorporate, besides the conventional construction system, a few things that sort of is also taking into consideration the environmental and climate change aspects. For example, here in this apartment building, we have not only incorporated rainwater harvesting and solar energy facilities. Solar energy will supplement the grid electricity, but also we have employed a screen made of bamboo, which allows for not only the flow of light and air into the interior, but also it helps in reducing the heat gain, and it also helps to allow the windows operated, allows for the natural ventilation, and creates a kind of a dynamic facade. And using bamboo is also a kind of a element that it is naturally made. It's not an industrial product. And if we can incorporate some of this natural bio-based materials into our construction, we reduce the carbon footprint of our construction sector. So this is what I had to share with all of you. I'm sorry about this, all these technical glitches that we experienced for this presentation. I hope you have all enjoyed the presentation. Thank you so much.
Well, that was really great, and I saw Saif the images of the school a long time ago. It was fascinating, maybe not that long ago, but it's a fantastic example of truly path-breaking architecture. And thank you for sharing that experience. We have a bunch of questions that I'd like to get started with, and I'd like to start with the question from Khuzaima Al Hussein. Just that, Risto, I need to hold on. Yes, from Khuzaima Al Hussein, who asked. He refers to a famous architect from Egypt. Sorry, my screen is giving me a little issue. It keeps jumping around. Who is Mr. Hassan Fati. And he gave the idea that if you use the local materials in a building, it would naturally be safe from weather effects, because there'd be a link between the location and the materials that are available there. What do you think about that, Risto? And while you're speaking, Maria Kang would like to know if you're looking at rammed or compounded earth or strawable earth in the example that you mentioned from Syria. Could you take these questions to start off with, Risto, please?
Sure. Thanks, Onno, and thanks to the people posing these questions. This is a really good observation. So local materials there are a wide array of benefits around using local materials, and one important one is that they're likely to be well suited to deal well with the local weather, the local climatic conditions, and local hazards from weather, climate perspective, or other types of hazards. Of course, they also have all sorts of other benefits, including affordability and cost, including environmental implications. So we're doing as much as we can to use local materials in a durable and robust way in our solution. This is really a really interesting perspective. And on the point of rammed earth, we are using rammed earth in some of our projects, particularly in projects in Syria, for example. We have some examples of using rammed earth, as well as a few other locations. We are looking at expanding this and using particularly stabilizing earth by compressing it and adding a small quantity of cement. We have found this really increases the durability of structures. We haven't yet tested straw as a material for reinforcing concrete. Reinforcing rammed earth. This is certainly a possibility that we can look at. But yes, there are a wide array of natural materials and natural solutions that we are exploring.
Thank you so much, Risto. I want to go to a next question, which is from Jamila Sikandar Khan. And her first question I will answer, and then I want to go to Sana for the second part of her question. The first question is, what are the AKDN plans to influence the policymakers in the country of its operations, particularly in Asia and Africa, where most of the gains from green construction are to be made, as Risto explained? I wanted to be really clear about that. Our view as a network is that we're on-the-ground implementers, and our first aim is to show that you can actually build green, and that it is feasible in geographies where people might not think about it. You don't have to have a LEED Platinum hotel in downtown New York or something like that. You can build an environmentally friendly school, as I've showed, on a floodplain in Bangladesh. We can build environmentally friendly housing in rural Gujarat, no problem. And with that, influence the discourse by example. Only that credibility, having done that and pioneered and shown techniques working, we then would be interested in influencing policy, but still mainly in a network approach. We're not the World Bank, we're the Aga Khan Development Network. We want to work hand in hand with all stakeholders, be an implementer, show the example, innovate, and share our innovation graciously. And to complement that question, Sana, Jamila also asked about the question of equity. Issue raised is that the majority of the population in these countries neither have the means, maybe not the motivation or awareness to build this way, might be too expensive, they might not think about it. And the question is, how do we address that? You've got significant experience in India, actually doing the things that you showed as an example. How do you get poor people to invest in sustainable methods and sustainable techniques and sustainability in general? Could you speak to that, please?
Right. Thank you for that question. if it is benefiting them, like the community understands that it is going to be cost effective in the long run, that's where we are able to get their buy-in. And how are they able to fund it? So in certain projects, we definitely see how we can get funding to kind of subsidize these green features. And India as such is already got a number of targets, especially as sustainability development goals that we've committed to. So the government itself subsidizes. For example, solar is one of the cheapest in India compared to a lot of developing nations, is because we have these government subsidies that are part of their mission to kind of, and we as an agency help the community to facilitate them to be able to avail of these subsidies such that they can go green in their own ways. And like we've already discussed, that using more of local material and labor as it is a green way of constructing. And we always try in whatever geography we're working to understand the local practice and upgrade in terms of by bringing in disaster resilience and green design, such that we don't really need to spend too much of money on the construction bit, but the design itself that we are facilitating or providing through our technical assistance helps them build green. So yeah, I hope I was able to address that question of how we're able to help communities build green in an affordable way.
Well, I think you did, and to the point, I've personally seen homes that were built for poor people that met these standards. So there is actually real homes you can look at to show that some of these examples work. I want to go to Saif. There was a number of questions for him. One is from Raji Sar, our colleague from Aga Khan Trust for Culture, who asks, could you share, Saif, a bit about how entrenched attitudes amongst engineers and architects might have been obstacles for applying principles of green construction? How did that work for you? I'm sure even our other panelists could speak to that issue, because at least the popular belief is that engineers are traditional and not innovators. So it'd be good if you could talk to that. And while you have the floor, Saif, there's a couple of questions about what's the lifespan, what's the cost of this project, what's the cost of these repairs post-monsoon that you happened, and how long do you think you can keep a building like that going realistically? Is it something that will last, or is it does it have temporary features because of the challenges in maintenance? Saif, over to you.
Yeah, can you hear me? Hello?
Absolutely.
Yeah. Okay, great. No, these are all important questions. I'll first address Raj's question about the acceptability of newer ways of looking into things. I think that once you are used to some practices, whatever comes new, it needs to be tested out so that people have confidence and trust in using that. So, for example, for this school, I really had a difficult situation finding an engineer to help me with the structure of this school. I mean, designing the structure, because we are all well versed in reinforced concrete or steel, but when it comes to designing a bamboo structure, not that this is part of the engineering education. Even in architectural education, you really don't get to learn much about this thing. So I think that the more such examples are built and more successes are shown, gradually this will surely pick up. And we also need to make them known. We need to have them sort of shared. And I think this project getting recognized as examples of sustainable and green architecture are fantastic, because this makes people think that, okay, we have alternatives, and we don't have much of an option if you take the global warming thing and the finite resources. So one needs to sort of take such bold steps. And I have to say that we also need to have clients, patrons who will come forward and invest and make them known. So I think the Aga Khan Trust for Culture, Aga Khan Development Network are the kind of patrons that, or these sponsors that we are talking about. But coming to the particular design of the school and its performance and its life, because everybody, many people are concerned about that. My client is the least concerned. She wanted to do it. She has spent her savings, and she had employed her people in that way, that how best to keep this happening, because she didn't want to alter that particular environmental condition. So that was the big thing. Of course, we need to repair, even if we are looking into more durable construction. Maintenance is part of that thing. But here, it requires a little bit more attention. And as we move along, I mean, I had an idea that in the first 5 years, we are not going to face much of a difficulty. We will go for a maintenance after the first 5 years and make it again continue. And this is what we do also in our villages, in our rural conditions. No house is left, especially made with natural materials, left without maintenance. The floors are maintained, the mud floors, they're maintained, the bamboo posts are replaced. So it is a continuous process. And if we are using bio-based materials, I think it is easy to continue with that process. But when it comes to a condition of urban environment, we need to think a bit more about it. And I'm sure that the solutions will evolve for a lifespan and the type of materials that we use. Was that okay? Does it answer the questions?
Yeah, I believe so. Otherwise, we'll see it coming back to the chat window. And I can certainly attest, I lived in the United States for a long time, and I had a supposedly modern, robust house. And all I ever did on the weekend was go to Home Depot to do home maintenance, because every house needs maintenance and every building needs maintenance. So I think it's a perfectly realistic answer. I want to go to an important question from my Nestor Rolando, which relates to the geographies where the AKDN works, often very rural and in many cases very cold. I'm talking about the mountainous areas. So Risto, any recommendations there? Limited access to innovative material and techniques in high mountains in Pakistan, Tajikistan, Afghanistan. Heating is a main concern, and you want to save energy. How do you do that, realistically speaking?
This is a great question and very pertinent. This is something we are addressing daily. It is true, not only is it very, the environment in these geographies is very hostile. We're seeing lots of natural hazards, very cold winters, but also access is very difficult. So introducing new innovative materials is doubly challenging to this, just access to these materials, especially, for example, I mentioned in my presentation, sustainable timber products, and particularly engineered timber, something even going to glue lam or cross-laminated timber. This is really, really difficult. So the way we are addressing it currently is finding out new ways to use local materials, whether it is local rock, whether it is local soil to stabilize and build with, or local sand and aggregates to make lower carbon concrete with. At the same time, we are taking a longer term vision of enabling the use of more sustainable materials through vast plantation programs and setting up the foundation for to be able to source sustainably timber products locally, and then we can start using timber products more sustainably locally without having to transport them, because transportation can be really difficult in these parts. Heating is a really important consideration for having comfortable and safe buildings in these geographies, and efficiency in this is really important. So really focusing on insulation, really focusing on other passive measures like the use of thermal mass, the use of the orientation of the building, as well as the source of heating. So these plantations, the tree planting schemes that I mentioned, they can contribute to also greener, sustainable sourcing of biomass for efficient boilers that we are trying to introduce for space and water heating. All of these are really important for these cold environments that we work in.
Thanks so much, Risto. I understand that Dr. Mohammed Karim has his hand raised, so if those who are at the controls can unmute Dr. Karim, then he could ask his question. Dr. Karim, you're unmuted. If you now unmute yourself, you should be able to ask your question. It doesn't seem to work. Dr. Karim, could I ask you to try and unmute yourself? If that doesn't work, please type your question in the chat window and we will address it. In the meantime, I just wanted to relay a comment from Jamila, who came back and said that it would be good to differentiate between local and traditional materials. He's saying, for example, in northern Pakistan, locally available materials, I mean, cement and RCC blocks are actually locally widely available, and they're in no way traditional, nor, of course, are they environmentally friendly. Although they are, I want to say from my end, more environmentally friendly than using RCC blocks that come from far away, because at least you don't have the environmental cost of the transportation. But I think our ambition, we're new in this business, our ambition is to be more creative than that and actually experiment with true local materials. Many of them will be traditional, because whatever you try, you'll figure out that generations ago it was probably tried already and used for a long time. But there's nothing against something completely innovative if we can find it. So we are on this journey. In the short term, shortening transport routes for materials is already a great way to save carbon, just to say that. Oh, it looks like Dr. Karim had to disconnect. Maria Kong, asked whether wind farms are an option in the mountains. I don't know the answer to that question. I do know that we are very successful using solar and hydro, both big hydro and very small hydro. So I honestly don't know the answer to that question. Do you know, Risto or Sana?
I think it is theoretically a possibility that we can explore. I don't think we have applied this yet. We have applied other types of renewables, just like you say, hydro, solar, as well as heat pumps, including ground source and water source. But wind is something that is generally a little more costly, and we're starting to tackle these challenges of access to the technology, especially for these most remote locations. But that is certainly something we can look into the future.
Maria is also asking about permaculture, increasing biodiversity, and there was an earlier question also on roof gardens. Sana, I know that you guys have looked at that in terms of bringing down the temperature in homes. Could you speak to those issues a little bit?
Yes. So as we know that the roof is one part of the building that absorbs the maximum heat energy, and treating it, whether it's by having roof gardens or by having the traditionally how you whitewash kind of the building, especially the roof. And the other way to do it is it's using the more high-tech reflective coating that kind of reflects 90% of whatever falls, like the rays that fall. But when you compare these options, we realize that green doing plantation on roof is more of an extensive operation and maintenance required. It may cause leakages, and that's where people are apprehensive about trying it. Although that's going to give a similar result to using these high reflective coatings. But certainly these are all the options. But we're looking at something that's more that the community would be able to maintain in the long run and is comfortable with.
Thank you, Sana. I can relate to that. Dr. Karim, if you are online, please unmute yourself and ask your question. I understand that Dr. Karim is back, but we're trying to make that work. In the meantime, there was a question on how you enforce these designs. How do you get people to actually build according to design? I'm going to embarrass you, Sana, and direct that question to you, because I remember seeing a house in rural Gujarat that was beautifully designed by AKAH, and then the owner built an extension which was completely not in accordance with any type of advice given and downright dangerous. It is an actual challenge, right, to get people to stick with the design and use the houses a proper way.
Right.
What's your most important lesson there?
I think it's important to understand that we as architects and engineers or technical experts, we are there to give them a safe house. But it's very important that it meets their need. So, the very first day when we engage with the community, we sit and design the house with them, rather than we making the designs and imposing it. Like, it's not a one size fits all kind of a solution, but it's tailor-made for every house. And that's what we realized during this journey of the Rural Habitat Development Program, which is the Rural Housing Project in Gujarat, that we need to understand the needs that, there's a family of 3 and there's a family of 5. They are probably into agriculture, or there's a single old lady who requires that home. So for every family, the site will require a slightly different design, but keeping certain principles and certain elements common, which we derive again from the vernacular architecture that exists. So it's basically building on the architecture and the preferences of the user, such that going forward, even if they want to make changes, we kind of anticipate and design for it, so that the modifications are not compromising on the safety of the structure. And we definitely don't step into doing anything which is related to the interiors, because I think every person who's spending the life time savings into their house, they would like that house to be give that feel in terms of the paint, the tiling. So we just stick to the design, the structure, and ensure that it meets their needs, not today, but going forward. We ask them to envision it, and then we give them that design. So I hope I was able to answer to that.
Yeah, no, I think it's a great approach. It works like 80 to 90% of the time, but it's the best approach we have. Our last question, I really want to get somebody live into the questions, and it looks like Khurshid Sana Khan would like to ask a question live, and therefore let's try whether we can make the technology work. And that'll be our last question, because we're 5 minutes away from the end time of the webinar. Khurshid.
My question is to Mr. Hristo. I'm not sure if I'm pronouncing his name right. Ms. Jamila just mentioned that while constructing buildings, we have to understand the difference between locally available material and traditional materials. We know that in the north of Pakistan, local construction material is concrete. Is one of the examples is concrete, and traditional is mud. I'm just wondering if any of your projects are using a mixture of mud and concrete as construction material. Thank you.
Thank you very much for this question. And it is so nice to hear a voice for a change in these webinars. This is a really great question, and it is really important, like you say, to distinguish between the local and traditional materials. Particularly with mud concrete mixes, this is quite an innovative approach. We haven't yet applied it to our projects in northern Pakistan, but it is one of the things that we would certainly be happy to explore. Certainly, I know mud concrete can be used for paving, for paving material, as well as even for load-bearing purposes. But for paving, we are it would be a really interesting approach. I know that we have used other innovative materials which are low carbon for paving. Maybe they don't suit the traditional definition, but certainly are low carbon and innovative. For example, materials based on recycled plastics, and we've used this for paving. And these are taken, sourced locally, and provide a porous surface, which is being a very good alternative to concrete-based paving material. But certainly more traditional mud-based materials would be also interesting to explore, which, yeah, we would love to look into this.
Thank you so much. And I really want to thank everybody who participated in this webinar for such an active discussion. As is clear in the discussion, this is a new area. It's an area with great potential. It's an area where the Aga Khan Development Network, with its legacy of respecting heritage and vernacular, and of course the great work of AKTC in the award for architecture, and we were so honored to have Saif in the panel today. It's an area where we can still progress a lot and learn and push the boundaries. We have a commitment as a network to become net zero carbon. It's a great commitment that will require a lot of work, and building will be an important part of it. So Risto Dikansky, Sana Darani, Saif Ul Haque, thank you so very much for your insights and your realistic and meaningful contributions to the webinar. And thank you everybody for your participation. It's been very interesting for me. Thank you very much.
Thank you.
Thank you.
Thanks everyone.